Hello guys and welcome back. We're now going to learn about memory addresses and pointers. So firstly, know that everything in C has a memory address. Functions have memory addresses. Variables have memory addresses. Literally everything has memory address once it's compiled. So we can access those memory addresses to do really cool things. So for example, I can access the memory address of argc here and change it anywhere in my program. I could access the memory address of a function and be able to call that function even without knowing the function name to begin with. But we can get on that later. Let's now start memory addresses and pointers. So firstly, do printf %p for pointer, and we're just outputting the memory address right now of argc. So that's all I want you to do. I want you to do ampersand argc, and then obviously do your command prompt, and we're going to cd into our hello world app again, and we're going to go gcc main.c -o main, and then we're going to do main, and you can see it outputs this hexadecimal number here. So this is the memory address that argc is at when you load this program, and argc is a stack variable, which means that it gets deleted when we leave this function. And that's important to note, because it means if I share this address around the program, as soon as I leave this scope, that address is now dangerous and you shouldn't be accessing it. So that's important to note. Stack data should only be accessed when it's safe to do so. So in other words, if this function main calls another function, that calls another function, that calls another function, and so on, this address can safely be accessed. But if I store the address of argc somewhere globally, and then I leave this function, the second I leave this function, that address is now unsafe. We can't access that address anymore, because the stack pointer, remember I was saying about the stack pointer, it gets pushed back up. The base pointer, stack pointer, they get pushed back up, and then that data is no longer accessible. Or you can access it, but it's unsafe to do so. Right. So that briefly explains that. So essentially, if we do printf, let's do integer a equals 50, and then we go printf. I'm just going to do I for both of these this time rather than p, just to demonstrate this. So you can see we output the address as an integer, and we output the value of a. So let's compile that again. So you can see when we use the ampersand, it gives us the address as a decimal, and that's the memory address of a. And then we don't put the ampersand, so it outputs the value of a. So I hope that shows that by using the ampersand you can get the address of things. Okay, so now pointers. Let me explain pointers to you. This is very important part. Now remember I said at the start, when we first started this course, I mentioned I'll tell you what these asterisks mean. Well, they're pointers. So let me explain that to you now. If you do integer asterisk p, just for pointer, that's a variable name by the way, equals ampersand a. Now what we've done here, we've created a pointer variable, and pointer variables are basically integers that hold memory addresses, and we've created a pointer variable that points to the address of a. And remember earlier we were testing outputting the memory address and the value. So remember in this case then, this memory address would go into P, right? And because we know the memory address, we can overwrite the memory address, essentially overriding variable a. So it's called a pointer. And obviously pointers have data types, so in my case integer. So it means that when I access this memory address, it'll be treating it as an integer. And that's why this data type is pretty important here. So I want you to do asterisk p equals 20. So what does that do then? Well, without the asterisk, we just change the value of the pointer. And remember, the value of the pointer is the memory address to what it's pointing at. In our case, %a, or the address of a. Now, when you put asterisk before the p by here, you're saying, no, don't set the memory address. Don't set the value of p. Set the value that p is pointing to. That is what you're saying. So once again, without the asterisk, set the value of our pointer variable to address 20. With the asterisk, set the value that p is pointing to 20. And in our case, it's pointing to variable a. So guess what will happen? A will become 20. Now just to demonstrate this, I want you to do printf I \n for new line. Not required, but you can do it. Pass in a there. So this will output the value of a, which is 50, but we change it here to 20 with our pointer variable. So if you go back now and compile that, run that again, you can see 20 outputted. So you can see that we've successfully changed the value of a by using a pointer variable. And now to explain argv. When you have two asterisks instead of one, what you're saying is you are creating a pointer of pointers. That is basically what you're saying. Okay, so now I want to show you something else. You can access arrays as a pointer as well. So follow what I'm doing. Let's get rid of all of this. We're going to go to char buff for buffer, 512 or whatever. It can be 20, whatever, how many bytes you want, 20 then. And then what we're going to do is we're going to say char asterisk for pointer equals buff. And remember, don't use the ampersand here either because it's an array, right? So just by going buff, it'll give us the address. So now you should be able to do things like this. Pointer 0 equals A. Pointer 1 equals B. Pointer 2 equals C. And then if you do printf %c for char, and then you go buff 1, we should see a B. Let's give that a go. Main. And we see B. So that is how you create pointers to arrays. So essentially you just do that and you can access them like this. Now that's the thing about the array index in C. You can access them through pointers, such as 0, 1, 2 on the pointer, and it'll pick the correct element. But remember, there's no bounds checking in C, as discussed before, so you do need to be very careful with that. Okay, let's now try a pointer of pointer. Okay, so what we do to do that is I want you to do, firstly create an integer called a, and then we're going to go integer asterisk p equals ampersand a, and then we're going to go integer asterisk asterisk p2 equals p. So I hope that explains the multiple asterisks now. So when you have two asterisks, it means that it expects you to point to a single pointer variable. That's what it means. And if you had three of them, then it would expect you to point to a 2 asterisks pointer variable. So that's how that works, right? Do you see what I mean? And then what you can do is you can do things like this. So for example, let's say I want to change the value of a from p2. I would go asterisk asterisk p2 equals 50. And then if I go there and compile that, oh, forgot to print it out, guys. Printf %i, and then we're going to go a. And also we're going to change it from 50 because the value start is 50. So just do 25. And we do this. Go main. It says 25. So can you see how that works? So when we do 1 asterisk on P2, it takes us to this. Okay? It takes us to variable P here. And then when we do two asterisks, it takes the value that P is pointing to and takes us to that, which points to A. And you know, if it was 3 asterisks, it would be the same. It would take us to the second one, and then a 3rd asterisk would take us to the final one. I'll just do that quickly just to show you, and hopefully 3 will make it very clear. If not, send me a message, I'll explain it further. So we can go like that. We compile that again, and you can see that works. So we go asterisk, 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 which finally takes us to A. So you're probably thinking, well, what's the point of having multiple of these? Well, there's a good point for it. Sometimes you might want to change the value that a pointer is pointing to, for example. And just to show you how that can work, I'm going to create another variable, integer b, and say we want to change where p2 is pointing to. Well, we just do p2 equals ampersand b. And it really is that simple, right? And then if you want to change variable b, you do asterisk asterisk p2 equals 30, and then b will become 30, right? Main 30. So the great thing here then is that we can actually change p. So by doing asterisk p2 equals ampersand b, integer p here, the pointer, will no longer point to a, it will point to b. So literally we can also do this, just so I can show you quickly. We can do asterisk p in here, and you should see, oh wait a minute, oh yeah, my mistake, we also need to change it here, guys. So we go asterisk p2 equals ampersand b, and then if we compile that, then we see 20 because p now points to b. So let me just go through this with you because it does get a bit confusing, doesn't it? So you go a equals 50, b equals 20, so we create two separate variables, and then we create a pointer variable called p that points to a's memory address. Okay, then we create a double pointer value called p2 that points to the pointer's memory address. And then finally what we say is, we say get the value of p2, go to it, because it's a memory address, go to it, and set it to the address of b. Now because p2 points to the address of p, we set the value of p to the address of b. Does that make sense? So then we change where p is pointing to. So that's the whole point of those double pointers, because it allows you to change where other pointers are pointing to. So it's quite a handy feature actually in the C programming language. So that is pointers and memory addresses. I hope that clears it all up. It probably is a bit confusing for you. Just go back through the video, watch it again, and it'll come to you. It takes a while to understand pointers. Thanks so much.